Good evening, everyone. I welcome you all in a Sapience education. So today I'm going to discuss about Pascal's law. So this is the part 2 video of the fluids. So if you want to go for a basic of the pressure, so please visit our first part video. Okay. So I'm going to discuss about what is actually Pascal's law and basic you should to understand. So here very important law given by Pascal, and due to him only we unable to do one of the most important thing, that is hydraulic brake and all. When we apply a less pressure and then we able to lift very heavy load. Okay, so if you are applying hydraulic brake, so in less pressure you are getting very high power, or in less pressure or less force you are getting very high force. So how this is happening, so you need to understand this thing. Okay, so before that we need to understand actually what is the basic principle of a Pascal's law. So in Pascal's law you will able to understand that this is the C here, and this is your force F1, this is a piston. So this type of things, you can understand that this is your piston cylinder assembly, piston cylinder assembly, right? So this is also piston and this is also piston, and if this piston force F1 will be applied, and area of cross section of this piston will be A1 and the pressure will be P. Okay, at the same time here force F2 will be applied, and due to which F2 will be in upward direction, and the area of the cross section of this piston will be A2, right? So how this works, so to try to understand first what Pascal's law has given the statement. As per its statement, what it states that the pressure in a fluid at a rest is same at all points which are at the same height. So let us consider. So suppose this is your liquid, okay, and you want to find a pressure at a same horizontal level. So if I want to draw a same horizontal level, so if you want to find a pressure at a point 1, point 2, this is your point 2, this is your point 3. So at the same horizontal level I am talking about, same horizontal level only. So at the same horizontal level pressure will be remain same. So this is very important thing. Okay, but as soon as you go in a vertical top or bottom, so pressure will be vary. But at the same time what is happening, at the same horizontal level pressure will be same. Now a change in a pressure applied to an enclosed fluid is transmitted undiminished to every point of the fluid and wall of the containing vessel. What do you mean by this? See here, if you are applying a pressure, that is extra pressure is your 100 Newton per meter square, so it will be transmitted to whole liquid. See here, from this figure you will able to figure it out. For example, at this point suppose pressure is your 100 Newton per meter square. So the same pressure will be everywhere, either in this wall, in this wall. So if you are increasing 100 Newton per meter square pressure, so here everywhere 100 Newton per meter square pressure will be transmitted. And this is what the very key point used as a Pascal law to make a very large hydraulic lift, and by using this we are able to do this. Okay, so let us go for a calculation now. Now see here how this application works, right? See, so suppose this is your hydraulic machine and it is used to lift a heavy load by applying a smaller force. So see here, suppose this is your car, okay, and car is being lifted by just a small applying force by manually if you are applying. Now now let us consider pressure applied. See here, this is your applied pressure and this is your result of lifting. Here no one is applying, okay, so it is a result or outcome. So if pressure is applied is how much force, if you are applying a force of F1 and you are applying an area of cross section at A1, then pressure and the pressure transmitted at this load at this car. See here, if you are applying a force of F1 to an area of A1, so pressure will be transmitted. So suppose there is a pressure is being created that is equal to force F1 by A1, and the same pressure will be transmitted. And here the pressure, due to this pressure transmitted will be F2 by A2. Here F2 by A2 is the pressure, right? Okay. Now tell me, as we have just now studied what is Pascal law, pressure transmitted will be same every point. It means that from the Pascal's law, equation 1 and equation 2 will be same. That is F1, that is can we write here F1 by A1 will be equal to F2 by A2. Can we write this? So by using this, if you want the force F2, so how you will find? F2 will be equal to F1 by A1 into A2, right? Now as per Pascal's law, it is transmitted equally all over the fluids. So from equation F1 by A1 equal to F2 by A2, so from this we are getting this equation. Now tell me, if you are applying a force F1 of 100 Newton only, but you want that my force should be, output force should be 10,000 like this. How much? 10,000. But you are applying less force. So what you will do? So if our output is your very high, so what you need to do? We need to reduce this area. That is, try to make this area as a less, and try to make this area as a large. The more larger this area will be, the more force you will get. And if you are getting more force, so this car will easily get lifted by just applying a small amount of force. Okay. So if you want to increase the force, so use this equation. So we should increase the area. Okay, I hope you have understood this Pascal law. Now let us try to solve one numerical problem. In numerical problem, they are telling that in a car lift, compressed air. So same thing, car lift is there like this. So suppose there is a car lift like this, right? Okay, car lift is there, right? So in a car lift, compressed air exerts a force F1 on a small piston. So let us consider this is your F1 and our outcome will be F2, right? Of a radius, how much? So radius, so they have given radius R as 5.0 centimeter, and the pressure is transmitted in a second piston of a radius 15 centimeter. So here R2 is your 15 centimeter at all. R2 is how much? See, try to understand. Here R2 is how much? See, let us do properly. Okay, let us do. Okay, now see, let us see here. This is a smaller piston and this is your larger piston at all. Okay, larger piston at all. Now you have applied a force of F1 here and our output will be F2. Now the area, radius of this is your R1, that is equal to 5 centimeter, and the radius of this bigger one is your R2, that is equal to 15 centimeter. Okay, so this is what we have got. Now this pressure is transmitted to a second piston of a radius 15 centimeter. If the mass of the car to be lifted is how much? Mass of the car is how much? Mass of car is equal to 1350 kg. Now calculate F1. If, what is the pressure necessary to accomplish this? So we need to find out what is the pressure F1. So as we know that pressure F1 is equal to F2 by A2 into A1. Now how you will find F2? So we need to see here F2 is what? Load of the car. Load of car, and load of a car is how much? Weight of the car. Weight is how much? Mg, that is mass is your 1350 into 9.8. So this is your force F2. So we have got force F2, that is equal to 1350 into 9.8 divided by area A2 is what? Pi into A2 means what? Pi r square. So R2 square. So R2 is what? 15 into 10 power minus 2 whole square, because it is in a centimeter we have converted it to meter. Now it is your area A1. A1 is your what? Pi into R1 square. So R1 is your 5 centimeter into 10 to 1 minus 2 whole square. So basically you will need to calculate this. So if you will calculate this, then what will happen? Try to understand. If you will calculate, then pi will get cancel out. You will do this, then you will definitely get a get 1470 approximately. Its solution will be 1470 Newton. So this is how much Newton of the force is being applied. Force is being applied to lift the load. To lift load, right? Okay. Now they are asking that what is the pressure necessary to accomplish this task. So pressure, you know that how much pressure. Pressure is equal to what? Force by area. So any force F1, A1 or F2, F2, A2 you will write. So you will get the pressure. So let us consider how much pressure we need, required. So pressure is equal to force F1. F1 is your how much? 1470 Newton divided by area A1 is your pi into A1. I am talking about A1, so it will be A1 is how much? A1 is your 5 into 10 power minus 2 centimeter. So if you will calculate this, so I think F1 by A1, so you will get 1.9 into 10 power 5 Newton. 1.9 into 10 power 5 Pascal. So you will get 1.9 into 10 power 5 Pascal approximately. Okay, approximately I am talking about Pascal. Okay, so do it by your own calculation. I have given method to how to calculate, so try to complete this. Okay, I hope you have understood now. So again I'm just telling you about Pascal's law. Pascal's law is basically application that when you apply a less force, you are getting very large force, and this happens due to the equal transmission of pressure in every direction, and it is given by Pascal's law. And by use of the Pascal law, we able to do lift very heavy load by just using simple force, and this is also known as hydraulic system. Okay, so I hope you have understood this topic. So thank you everyone.